Welcome to my full stack banking application capstone presentation. Today I'll be walking you through the architecture of my application, focusing on the front end, authentication, and how the different components interact. In this first part, we'll cover the front end architecture, the role of authentication, and how the app is structured overall. This diagram illustrates the overall architecture of my application. On the left is the front end built with React.js and Bootstrap, which handles the user interface and user experience. The middle tier, powered by Node.js and Express.js, acts as the intermediary that possesses API requests, manages routes, and ensures data validation. Finally, the backend is supported by MongoDB, where all the data is stored, and the deployment is handled through Heroku. This flow ensures that data travels smoothly from the user interface to the database and back, providing a seamless user experience. The front end of my application is composed of several key React components, including app.js, index.js, home.js, login.js, and createAccount.js. Each component plays a critical role in rendering the user interface, handling navigation, and managing user inputs. App.js serves as the main entry point, structuring the routing and layout, while index.js links the application to the DOM. Home.js provides a welcoming interface for users, guiding them to key features. Login.js handles authentication, incorporating validation to ensure data integrity. CreateAccount.js facilitates new user registration with robust form validation and data handling. Bootstrap is used extensively for styling as it provides a clean, consistent, and professional look, enhancing the overall user experience. The front-end architecture also leverages the Context API, which with auth context.js and user provider.js managing global state. This approach ensures that user session data, particularly authentication status, is available across all components, creating a seamless and cohesive experience for the user. Index.js setup. This snippet shows how I linked my React app to the DOM and set up the root rendering using React 18's create root. User provider JS state management, creating the user context. This part sets up the user context and a hook to access the context throughout the app. State management for users. This snippet shows how I handle storing and retrieving user data, ensuring that the user state persists across sessions. Login and registration handlers. This part handles user login, showing how I manage authentication and navigation post-login. Auth context.js for authentication, managing authentication state. This code snippet highlights how I manage whether a user is logged in or not using React's use state hook and context API. Authentication is vital for securing my application, allowing only authorized user to access certain features. I implemented two primary methods. One, token-based authentication. When users log in, their credentials are verified through the API auth login route. A token is generated and stored in a local storage, which authenticates subsequent API requests, ensuring secure communication. And then two, role-based access control, RBAC. The app uses RBAC to manage permissions. Throughout the context API, roles are defined and managed, ensuring users access the appropriate features based on their role, so whether for customer or employee. Initially, managing secure and persistent authentication across components was complex, particularly with role-based access. To address this, I centralized state management using the Context API, which minimized prop drilling and ensured consistent authentication state across all components. Storing the token in local storage also maintained user sessions even after the browser was closed.